The U.S. Army's 52nd Air Defense Artillery Brigade has initiated operational assessments of a new counter-drone interceptor system in Europe aimed at improving defenses against one-way attack drones. Conducted under the Eastern Flank Deterrence Initiative, the evaluations involve the IonStrike interceptor developed by DZYNE Technologies. According to Army officials, the system is being examined as an intermediate-layer air defense capability positioned between electronic warfare solutions and expensive conventional missile interceptors. The testing campaign has included participation from senior representatives of U.S. Army Europe and Africa, as well as NATO Allied Land Command, reflecting growing interest in scalable and cost-effective defenses against large-scale drone swarm threats. In this video, Defense Updates analyzes how IonStrike could help U.S. military better manage evolving drone threats. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. The rapid proliferation of low-cost drones has fundamentally altered the modern battlefield. Conflicts in Eastern Europe and the Middle East have demonstrated how relatively inexpensive drones can threaten armored vehicles, logistics hubs, artillery positions, and even strategic infrastructure. Traditional air defense systems, originally optimized to counter fast jets, helicopters, and cruise missiles, are increasingly facing an economic and operational mismatch when engaging mass-produced one-way attack drones. For example, expending one or two FIM-92 Stinger missiles, each costing approximately $200,000, to intercept a Shahed 136 loitering munition with an estimated production cost of roughly $40,000 is not a cost-effective approach for prolonged high-intensity operations. In this environment, the emergence of the IonStrike interceptor represents an important shift towards scalable, cost-efficient air defense architecture. IonStrike is designed primarily for counter-unmanned aircraft system, CUAS missions. Unlike traditional interceptors that may cost hundreds of thousands or even millions of dollars per engagement, IonStrike is designed around the principle of affordable attrition, where the interceptor itself remains economically viable against cheap aerial threats. Technically, IonStrike operates as a kinetic interceptor equipped with a precision terminal infrared seeker and a proximity-fused warhead. This configuration enables the system to destroy or disable hostile drones without requiring direct physical collision. The infrared seeker provides terminal guidance capability, allowing the interceptor to track thermal signatures during the final phase of engagement. This is especially important when dealing with maneuvering drones or low observable aerial targets operating at low altitude. The integration of a proximity fuse significantly improves kill probability. Instead of relying on a direct impact, the interceptor detonates when entering lethal range of the target, dispersing fragments or blast effects capable of neutralizing the UAV. This increases engagement reliability against agile drones and reduces the precision requirements typically associated with hit-to-kill systems. A particularly notable feature of IonStrike is its retaskable engagement capability. Traditional fire-and-forget interceptors become fully committed once launched, meaning the missile is expended regardless of whether the tactical situation changes. IonStrike introduces a more flexible engagement model where operators can abort or redirect the interceptor mid-flight if the target is reclassified or no longer meets engagement criteria. This capability becomes highly relevant in dense and dynamic battle spaces where friendly drones, civilian UAVs, and hostile systems may operate simultaneously. The ability to preserve interceptors and reassign them to higher priority threats enhances overall battlefield efficiency and reduces unnecessary munition expenditure. Another major strength of the system lies in its compatibility with existing command and control infrastructure. According to operational evaluations, IonStrike integrates with established U.S. Army air defense networks, including radar queuing systems already in operational use. Rather than requiring an entirely new sensor ecosystem, the interceptor can utilize existing surveillance and targeting data streams. This greatly simplifies deployment, training, and logistical integration. Major Cody Davis, 52nd Air Defense Artillery Brigade Operations Officer, noted, IonStrike is important because it does not require soldiers to learn a new kill chain. It integrates with approved C2 systems, cues on existing radar feeds, and provides commanders another kinetic option within the air defense architecture. The interceptor is launched from a palletized system that connects to radar feeds already in the Army's networks. Current tests use a launcher that holds 4 interceptors, but the U.S. Army and the manufacturer are also working on a bigger version that can hold 12 to help defend against large drone attacks. A significant portion of IonStrike's technical specifications remains undisclosed in the public domain. Information such as its exact engagement range, maximum speed, weight, dimensions, operational ceiling altitude, propulsion system, radar cross-section, warhead size, and estimated cost per interceptor has not yet been officially released. However, its compact size and likely lightweight construction appear optimized for high launcher density, rapid deployment, and mobile battlefield operations against drone swarms and low-cost aerial threats. The ongoing evaluation forms part of the Eastern Flank Deterrence Initiative, a program centered on integrating unmanned and minimally manned platforms through real-time data sharing networks. The initiative is intended to enhance the responsiveness of forward-deployed forces while offsetting adversary advantages in force concentration and operational tempo. The personnel from the 52nd Air Defense Artillery Brigade provided operational feedback regarding IonStrike's performance during simulated defense scenarios involving fixed and semi-fixed installations. Major Benjamin Bowman, the brigade's forward operations officer. The summer assessment will determine whether IonStrike can deliver a repeatable combat layer under operational conditions. The questions are straightforward. Can it integrate? Can it be fired through existing C2? Can it extend the defended area? Can it be reallocated in flight? And can soldiers sustain it in the field? The lessons emerging from Ukraine and Iran are very clear. Relatively cheap drones have demonstrated the ability to inflict disproportionate damage against expensive military assets. As a result, future air defense systems must prioritize scalability and affordability alongside raw performance. IonStrike appears specifically engineered around these lessons, emphasizing rapid deployment, integration with existing networks, and cost-effective interception. While operational testing remains ongoing, the system highlights the direction in which modern short-range air defense is evolving. Future variants could potentially incorporate artificial intelligence-assisted targeting, autonomous swarm engagement algorithms, improved multispectral seekers, or enhanced networked engagement capabilities. As drone technology continues to proliferate globally, systems like IonStrike may become standard components of tactical air defense formations across NATO and allied militaries. IonStrike represents a shift toward adaptable, distributed, and economically viable air defense designed for the realities of 21st century warfare. In an era increasingly defined by mass drone attacks and persistent aerial surveillance, such systems may prove essential for maintaining battlefield survivability and operational freedom. It remains to be seen if the system can win the trust of evaluators during the summer testing.